Okay, this is a hypothesis testing problem, and it's an upper tail test problem. I've already entered in the answers, but I want to step through each question so that you know how I derived the answer. First, in reading the problem, we're told that the mean time of 15 minutes or less is the standard assumption. If the mean survey time is longer than that, then a premium rate is charged. And they suppose that the sample of 35 surveys produces some data that they're giving us in the spreadsheet. And they also tell us that the population standard deviation, sigma, is 3.9 minutes. And this is key. So in setting up the null hypothesis, the assumption is that mu is less than or equal to 15. Therefore, the alternative is that mu is greater than 15. The next thing we have to do is compute the value for the test statistic. Now, what's key in the test statistic is that because we have 35 surveys, n equals 35, we can use the z-value. But let's look at how we calculate that. And first, let's look at how we calculate the mean. So let's open the spreadsheet. I've already done this, so I've already set it up. I use the count function to count the number of entries in my array to give me 35. Likewise, I use the average built-in function to calculate the sample mean. And what's key here is that the value you should use for the sample mean should be to at least 2 decimal places, 16.44. Otherwise, the test statistic value that you calculate will be incorrect or marked incorrect by the facility. So I would use, and it doesn't even let me, it does let me reduce the number of decimal places. But what's important is that you should carry over 1 decimal place more than the number of decimal places in your data. And you could actually go to 3 decimal places if you choose to, but at least 2. And of course, the hypothesized mean value was 15. The population standard deviation was 3.9. Those were given. And the level of significance here is 0.01. That's also important to know. Now, at this point, I would break away and set this problem up manually. And then I would use my statistical toolkit to calculate the rest of these values because the formulas are in the toolkit. You can look those up on your own if you like and calculate them, but I'm going to use the tool that I already have available and that you have available. So in the toolkit, you have hypotest mean sigma known. This is the hypothesis test for the mean. Sigma is known. You have a section for a lower tail test, upper tail test, and a two-tail test. We're interested in an upper tail test at this point. Now the question is, how do I know it's an upper tail test? As I said before, after setting up the null hypothesis and the alternative hypothesis, I'd break away and set this up manually just so that I could see visually how the problem is structured. Again, population standard deviation 3.9, sample size 35. The question is the premium justified? The premium is justified if we can reject the null hypothesis and accept the alternative hypothesis. And we were also told that alpha is equal to 0.01. So the area in this upper tail would have to be less than 0.01 in order for us to reject the null hypothesis. So our test statistic is z equals x bar minus mu over sigma divided by the square root of n. And we can use this test statistics because our sample size is greater than 30. And we also know we were given the population standard deviation. Sigma is known. So in calculating these, we're going to use 16.44 for the mean, minus 15 divided by 3.9 over the square root of n, which in this case I should have written in the 35. Now the odd thing about this problem is it's important that you use 2 decimal places for this x bar. If you don't, you'll get a value that the online facility won't accept. If you use only 16.4, you'll get a z-value of 2.12, which the Cengage facility will mark wrong. This value turns out to be 2.18, which the facility considers to be correct, as you can see. But we will get that value by using our toolkit. So I've entered in all the data, 15, 35, 16.44, 3.9, and 0.01. It calculates the critical z-value for me using the absolute value of the normal standard distribution, the inverse, where I'm entering in the level of significance, which is 0.01, and it's giving me the z-value that corresponds to that area under the curve, which is here in my diagram. So the z-value that corresponds to this, the critical z-value that corresponds to this is that critical z-value that was in my spreadsheet, which is 2.326. Next, we calculate the standard error, which is simply sigma 3.9 divided by the square root of n, 35. The margin of error is the critical z-value multiplied by the standard error. And then our calculated z-value is again x bar, 16.44, minus mu, which is 15, divided by sigma, 3.9, over the square root of n. So that's my calculated z-value. And as I said, in this problem, it's 2.18. If I had done this manually and used only 16.4, this number would have turned out to be 2.12. Which the facility would mark incorrect. So you have to use 2 decimal places for that. In your spreadsheet, in our other spreadsheet, we had actually used, we came up with 4.437, which gets us to 2.18 if you round that to 2 decimal places. So what you input for the sample mean is critically important, at least if you're using the Cengage facility to check your answers. And from the toolkit, we can also see that our p-value, which is 1 minus the normal standard distribution at that critical z value, and cumulative, gives us a p-value of 0.0145. And the reason we use the true parameter here is that what we're calculating is everything less than 16.4. We're calculating this area under the curve for everything less than 16.44, and we're subtracting it from 1 to get the actual area under the curve to the right of 16.44, which is 1.45, I think. And the problem here is this 1.45, the actual area is greater than our alpha. This is my p-value. But in order for me to reject the null hypothesis, my p-value has to be less than alpha. Therefore, I fail to reject the null hypothesis. And because I cannot reject the null hypothesis, I cannot justify using that premium charge for this client, which is why the decision is to fail to reject H sub 0. I have the hypothesis test built in to this equation here, simply comparing the p-value to the level of significance. If the p-value is less than or equal to the level of significance, then I can reject H sub 0. Otherwise, I fail to reject H sub 0. So I've got the logic for my rejection built into this toolkit. So going back and entering those values in, my p-value is correct at 0.0145, and because my p-value is greater than alpha, then I fail to reject H sub 0, and therefore the premium rate is not justified.